Good morning. Let's see. It's exactly 10 a.m. Should I ping other people to join? I'll put something in the channel.
Yeah, there you go. Hey, Joshy.
Hi,
Oh, hello, Josh.
What?
how you guys doing?
Doing well. Good to see you.
Yeah, same.
How was your trip?
Oh, yeah, great. Check it out. I came back with a ring.
All right.
Congratulations.
Yeah, thank you.
Yeah, congratulations.
Yeah. How was your trip, Tomislav? I haven't seen your face in weeks, man.
Yeah. It was very nice. Yeah. It was a few weeks ago, so I almost forgot.
Yeah, just back to normal daily life now, right?
Yeah.
Cool. I'm gonna switch monitors. Sorry if Zoom freaks out. I'll jump back if Zoom crashes.
Steve, thanks for checking out iOS version. And
Yeah.
So yeah, it's nice.
I've worked with PWA before, and I should have thought, you have to put the icon on the home screen. So it had been a while since I've done that. So it all made sense when, I saw the video. I'm like, oh, okay, that's what I need to do. So, yeah, I mean, we're moving right along. I had a question. Did you want to expand your pool of testers, or just so it's me, Jim, and Gary for right now? Is that enough for you to work with for testing, or do you want a few more people?
Yeah, I was just wanted to show this part of the picture, right?
Okay.
This is completely not related to, well, you can say it's not related to wallet at all, right? It's just communication. In this case, it's like a chat, right? We're sending messages.
Right.
But the concept, I want to show how can you build your own wallet in the same way, right? Because why not, right? It's not complicated to just call deploy and listen for the name, right? If you have.
Right. Well, would you be taking it a step further as far as adding this signature capability with the Archain API or status? One of those. Okay, that's what I
definitely.
figured.
And I would like to build like a tutorial. So I'm looking for volunteers to join this journey of creating your own wallet, right? Because part of this thing, part of the whole project is just JavaScript, right? Because I seen that different people uses JavaScript in a way that is it's much more difficult that it have to be, right? Because you have these tools that just easily write ECMAScript 7 or 2017, right? And have all these nice features like async await or things like that, right? And you can easily bundle it in the ECMAScript 2015.
Jim, I don't know what you have on the agenda for today, but probably everyone on the call hasn't seen Tomislav's latest work. What are your thoughts on getting people up to speed as far as what Tomislav's working on, or what else? What do we have on the agenda for today?
The discussion in the channel. Yeah, well, we have the consensus Colab first.
Right.
Yeah, then we have the computational calculus Colab.
Okay.
And then we have other things. Now, So there is some stuff in the channel um, uh, on these topics, but I'm perfectly willing to start somewhere else if people want to do that. Maybe we should talk about the agenda for the whole thing, and then we can decide what to do first.
Yeah, that sounds like a good approach. Okay. Go ahead.
So I sort of want to bring up the square root concept of consensus that Greg brought up this week or last week or whenever. Just wanted to get some feedback on that.
Yeah.
I don't know if there's anything else on consensus that people want to talk about.
Joshi had an implementation of Casanova that he's working on.
Yeah, I was just about to say I started writing up Casanova. I'm not very far yet, so I wouldn't need very long to show it, but I wouldn't mind showing it and at least letting people know where it is so you can follow or ideally help along if you want to write some code.
All right. And then I guess there's a number of things that have been brought up in the computational calculus, which we'll get to later. You want to show, should we start with Thomas just showing what he's got there and hopefully seeing who might get engaged with that wallet thing?
I'm not sure that in this phase, I wanted to just show the first example. So maybe when I add this part to communicate with Arno, then it's better to show. So yeah, I'm not taking the time for that.
That's when you have something there. That's when I want to get involved. I mean, even if it's command line, you know, even if it's command line, I think it would be worthwhile.
Yeah, definitely.
Okay.
Hey, Tomislav, just can you just give us like one or two sentences? What's the thing you're working on? It sounded like a wallet, RChain wallet related or something.
Yeah, and this is a PWA application.
What PWA? What is that again?
Professional web application. Professional web application.
Okay.
So, Steve, the PWA is a progressive web app.
Oh, progressive. Okay, I'm getting.
Okay.
Yes, progressive web application. Almost had it.
So I can just quickly share my screen, but. So it has just a few screens, and it's showing, you know, it has different capabilities inside, right? It has WebSockets as a real-time communication, and the point is that you can send receive messages, right? And I didn't prepare to say something meaningful. So, yeah.
That's okay. I already have questions.
The point is that you can install it on your desktop, right, and on your mobile, right. This can be like a regular application. So
now, there was an issue with the iPhone, right?
It was user error. It was so with a PWA, you don't install it. What you do is you send the screen to your the app to your home screen. So what it does is it creates an icon on your home screen, and that icon engages with the browser engine. So it's not an application on your iPhone. It's an icon that uses the browser engine to function. So, and PWAs, this is the way everything's going for iPhones and for Androids. And what makes it nice is So if you use Angular or React, so you create your code for a web application for, on your computer, but you can use that code for an iOS or Android, or you're using the engine of those mobile devices. So it's one set of code across multiple platforms.
Right. So if you have a browser-based app, that will work offline, I guess, on an Android. Right. Well, I don't know. I guess we.
Yeah, there is a different way to communicate with your application, right? In the background I have a WebSocket real-time communication. So if you send a message, like if you make like a new transaction, right, you will see something like this, something like notification, right? And this is like a real time, right? And what Jim is saying, you can go like a step further. When you close your application, like all instances of your application, then your application is dead, right? You don't have a code that is running. So then you can use Apple's or Google's push notifications directly to your phone, to your device, right? The desktop or the mobile. And then you send your request to Apple or Google server, and Apple or Google server will notify user in the same way. So you can have like offline notifications when your application is not working. So what I want to show with these tutorials, you need to build your own logic when you show notifications and what notifications, right? This whole thing, when you put it in one project, you still have this work to do, right? Right? You must recognize, you must clear existing notifications if you see it on another device, and right. This thing I didn't find that you can easily, have a library for this kind of thing. You have all of this separated. Okay. So what I want to build is, this this toolbox that you can use and build your own wallet, right? And not only wallet, build your own chat, right?
So this is, for any dApp you want to build, this is a way to do it. So this work should really be in the dApp developer channel in the Colab, right? Is that where we're discussing this?
Yeah.
Steve,
okay.
This is, it seems like this is an effort that we want to, I think everyone will agree we want to do. Of course, we have our meeting on Tuesday where we can formalize it, but
right, good point. Okay, yeah, that's a good point. This is kind of laying the groundwork, the foundation for future developers developing their apps.
Right.
Yeah, and then we also need to think about security, right? Security. Now I'm using different libraries, but I also thinking how to be sure that some kind of bug in some library doesn't break all the security. So
okay.
I would like to have not maybe a wallet directly on my phone. Maybe I just want to have my server somewhere, and my phone is just a relay, right? I can say I can spend on my mobile phone this amount of reps. So you will not compromise all of your wallet.
Oh, right.
Just by your phone. So
okay.
This is something I'm thinking. Right?
Okay, very good.
Yeah, I think initially we will have a node server running locally on the machine in order to secure the ArcChain stuff until we can do it all without, directly from the browser or whatever.
Yeah, it's all related to this discussion about FFI and system processes, right? How how can you execute your side effects from the blockchain? So
right, and you know, well, that's the online proxy part of it. Basically, the first thing is keeping the keys on your device. Is step one. Or having a trusted server that you control that handles your keys, which is step two, and that begins a proxy that can work for you on your behalf offline. It becomes part of your user agent, which is what we need to build ultimately, is this agent that works on your behalf, and that's really the extension of the Mac robot capabilities that we're working on. One small thing.
by agent, by agent you mean your contract on the blockchain, right?
Well, you have rules on the blockchain, obviously. Okay, and most of your user agent rules will be on the blockchain, but you also, not everything's on the blockchain. Your user agent works as you. It's your client that's always there to act on your behalf. It's like every time somebody wants to get my phone number, no matter how they try to get it, my user agent should authorize it.
Yeah. And the code, when you say authorize it, you mean put some object capability on some channel on the blockchain.
Well, it can. You can have a revocable permission on the blockchain, but that's only one way of doing it. I'm saying no matter your user agent needs to run all the time, ultimately. Act on your behalf, even when you're dead. Okay.
Yeah, but I'm asking where is it running, and where is the code stored?
It's in resources that you control. It's your proxy to the internet. It watches everything you do. It keeps a log of everything you do. It's your proxy to the net.
And when you think about communication to the blockchain, you have like a listen and deploy, right?
Right, and that's part of what it does. Is talks to all the blockchains. It's your wallet, okay, and you want that on your device, but you also need that on the net ultimately. Your user agent runs locally and on the net and on the blockchain.
Yeah, there is a. I'm thinking that I want to have as little as possible code for my agent that is not on the blockchain, right? Because at the end, I see listening for some private name that I have control. This means storing keys, right? I can just watch this name, right?
Yeah. Well, I believe that most of our transactions will all be off chain, and that's one reason I'm interested in this ambient calculus proposal for peer-to-peer process control, because I don't think it'll be on chain. Although in essence, our social ledger is our own chain, and how we keep that is we determine.
Would you call it the ambient calculus?
Ambient.
Yeah, what I say. Ambient.
Yeah, you said it right. Ambient.
Which the row calculus. I want to understand how we can model the ambient calculus and the row calculus. Of course, that's the next hour. The only other thing that I wanted to mention this morning, I guess we should make a round, is that I updated the robot R node to the latest 0.9.11. And now I'm getting this error that says union is not defined for set. And I still have to do some investigation, but I get this error after the fact. It runs the stuff, and I haven't detected any errors in it. The code seems to be running properly, but I get that error message out, which I don't know if anybody else. So that's
is it union defined set?
yeah. So that's something for I guess another time. I have to diagnose that and see if that's a bug in the new R node. I wasn't getting that message before with the same code. Running the same code did not give this error. Just an aside for now.
Yeah. Yeah, that seems like something, you know, see in your code where you tried to do a union and then try to make like a minimum reproducible example, you know, a 10-line program or something that has a couple sets and tries to union them, and then you could probably file an issue.
Right.
Yeah. Yeah, pretty weird. All right. Should I show my Casanova work?
Yeah.
Yeah, definitely.
Yeah, yeah.
So this is inspired by Jay coding up Hashgraph in Rust. And oh yeah, well, I'll try to do the same thing for Casanova. And I'm definitely in the baby phase at this point. So my plan was to take the Casanova paper, and at the end, they specify all of these algorithms. And they start, I think there's 4 of them, and they start with like a really simple one. This one's called Casanova Attest. And all it does is it gossips blocks, it builds a DAG, and when new transactions come in, they get put in blocks and they go in the DAG. It doesn't actually do any of the like conflict resolution or anything like that. So it's not like the interesting part yet. And then in algorithm 2, we have Casanova conflict attest, which I think starts to detect when there are conflicts. And algorithm 3 is conflict exclude, which is where it not only detects conflicts, but uses a side protocol to actually resolve the conflicts and say like, okay, these two, they're called events, but basically they're like transactions. Like these two transactions conflicted. And so now using this side protocol, we know which one is the actual one, and we'll cross out the other one. And then in algorithm 4, this is finally when they're done, they just called it Casanova. And this gets rid of the side protocol that they used for resolving conflicts, and instead just uses the votes that it basically uses the structure of the DAG to say like, okay, I know what someone knew at this point in time, so I know what they would have voted, and so we can exclude conflicts without an additional side protocol. And so I figured, well, okay, I'll start at the start. And so I started with Casanova Attest, and this is it. It's all on the screen right now, just these couple procedures. So basically the pseudocode says you're going to have a data structure that's a DAG, and you're going to have 2 sets called pending and waiting. And I thought those names were super confusing because I kept getting them mixed up. And it turns out pending is blocks that you've received across the network that you want to put in the DAG, but you can't yet put them in the DAG because you don't have all of their parents. So instead, they're just going to sit here pending. And then waiting instead is for events or transactions. And what that does is like I, as a Casanova validator, am just listening for incoming events at all times. And every time I get one, I put it in waiting. And then when it's time to make a block, then I just clear out that waiting set and put all those transactions into my block, and then send my block around the network.
I feel like a better word would be queued.
Yeah, totally.
And so are these initialized as empty? Is that why?
Yeah, those 2 are initialized as empty sets. That's right.
Cool.
And the DAG is initialized as the set that just contains the Genesis block.
That makes sense.
And actually, now that I think about it, I don't think I actually did that right. I did not start my DAG with a Genesis block. So that's something that I'll be able to go back and fix. Or actually, now that I think about it, I'm curious if we even need a Genesis block. But I don't know. I'll think more about that. So here's the procedure.
Joshi,
Oh, yeah, go ahead.
You're saying pending and waiting are sets, so you're not care about ordering.
That's right, exactly.
Okay.
So basically, like, so, you know, Tomislav, if you get a block across the network, you say like, okay, here's this block, what are its parents? And if all of the simplest case is like, you know, all of those parents and they're already in your DAG. And so in that case, you just go ahead and add the block you got to your DAG. It never goes to pending. But, you know, if everybody's working near the leaves of this DAG, it's somewhat likely that you won't have heard of some of the parents. So you just set this block aside in the pending set. And then the next time you get a block, or basically every time you add a block, either to the DAG or to the pending set, then you recheck, like, okay, are any of these things that I had previously marked as pending now all known parents? Are they eligible to go in the DAG? And if so, then we'll throw them in the DAG.
Yeah, of course. You have information about ordering inside the block, right?
Yeah,
parents,
exactly.
Parents to whom, and you can just...
Exactly.
Yes.
So, in fact, let me just show that. Okay, so here's the deal. Like, at first I was not at all embarrassed to admit this. Now I'm to the point where I'm a little bit embarrassed to admit this, but I'm still kind of a noob on Rust. So I struggled a little bit doing this in Rust, and then I switched back to Python just to make sure I understood the Casanova part. And so now that it works in Python, now I'm going to do it in Rust also. But let's just start with the Rust, because we were talking about blocks, right? So here's a block. It's basically, it has some parents, which is just other blocks, and it has some events, which are just like, you know, the transactions or whatever. Events are super, super basic right now, and I think what I'm going to end up having to do with events is also have parents, which would just be like a set of other events. And so there's
for like ordering events within a block.
I don't think they get ordered within the block, but we have two DAGs we're talking about here. There's the event DAG, which, you know, you can, if we just think of C delta as an example, like an event is a payment, basically. It consumes some UTXOs, those would be the parents. And then it creates some new UTXOs. Oh, and so actually, like, you know, depending on if this was a cryptocurrency, I would have, like, I guess, outputs as another field here. So there's that DAG. So like every event has some parents, you know, that's your typical, like, okay, I can't spend these tokens until I've received them. And so the transaction where I received them is one of the parents. But then there's also another DAG, which is the actual block DAG, because the blocks aggregate together events. So you have the events DAG, and then you also have the block DAG. Okay. I think that's all I wanted to show from there. And then I did the same thing in Python. Oh yeah, in fact, Python is more thorough. I already had the parents in there. And then block is like super similar, right? We've got like the parents and the events that go in there. And then, okay, so here's the validator. So basically, like, I'm coding up the class that represents a Casanova validator. And then at the end, I create, this is basically just like I'm going to do more formal tests when I do it in Rust, but this is basically just like automating one scenario to make sure that the code is generally doing what I want. So we just create two validators. Alice gets a default auto-generated name, and I just gave Bob this name just to make sure this works. And then I create 4 events, and you can see the DAG here. So there's like 1 and 2 don't have any parents, 3 depends on 1, 4 depends on 1 and 2, 5 depends on 4 and 2. And so you can see how I made them here, right? Like E1 and E2 don't have any parents, and then like E4 depends on E1 and E2. And then this is the payload, right? Like, I didn't make this into a cryptocurrency or anything. The payload is just stupid. It's just like a string. It's almost like BitStory, actually. Like, we're just putting these strings into the blockchain. And so then I just start simulating some of this, like both of the validators received events 1 and 2. Only Alice receives event 3. Only Bob receives events 4 and 5. So like Alice has 1, 2, and 3. Bob has 1, 2, 4, and 5. And then, so here I just print out like when you print a validator, it tells you the status of like what they're looking like how many events do they have, and how many blocks do they have, and stuff like that. And so basically I was just confirming that they all got the number of events I thought. And then Alice makes a block here and she sends it over to Bob. And then I just print them out again, and I expect them each to have one block. Alice, because she made it, and Bob, because you got it across the, like, you know, the network. My simple mocked network here.
The interface is really clean. I like the look of it.
Oh, yeah, nice. Cool. So,
wait, can I see the events one more time? I'm just curious.
The class?
Or no, sorry, the part where you're composing them together.
Yeah, this part?
Yeah. I just wanted to see how 2 goes to 4 and 5. Oh, yeah. Do you think that you can model the case where like 4 or 5 does not have 4 in it, and so 2 branches out into 2 separate ones?
Yeah, I think so. Let's just try it real quick. I mean, the line looks funny now, but like I think it's just as simple as that.
Yeah, E5 takes E2. Yeah, because the issue now is that you've already consumed E2.
Yeah. So it's not. It doesn't consume the entire event. It just consumes outputs that were created in that event. Yeah. So let's think here. So there isn't a notion of consuming the events, at least yet. And when I was thinking of it in like C delta terms, I was thinking that each one of these would have a couple different outputs. So, you know, like maybe event 2 is, well, it's funny to think about these Genesis ones, I guess. Like maybe if we just assume that like,
yeah, I mean, I mean, you're supposed to be able to, I mean, it depends on the model of what the outputs represent. But in the case that you would have to do this, I guess you would have to clone the event just based on the Rust borrow checker.
Yeah.
Because on line 107, you consume E2. So.
Okay. I see what you're getting at. So you didn't mean consume necessarily in the blockchain.
The UTXO model, yeah. It's in the.
Thinking more of like dropping the reference to that event.
Yeah. But I mean, they coincide too. I mean, if you have a model where the UTXO can branch out into multiple outputs, then, I mean, if your events are, you know, immutable and are never destroyed, then you can just clone it.
Yeah. Okay. That's actually really insightful, Jay. I hadn't thought about that. So like if the model is that each output from an event can be consumed exactly once, like never twice or whatever, then that actually corresponds perfectly with what the borrow checker is going to want me to be doing anyway, which is having like one owner and then only once ever dropping that reference.
Yeah. If that's the model, then that's really nice because you get it statically checked in Rust.
Yes, great. I'm so excited to be looking forward to using the borrow checker instead of like coming in guns drawn against it.
Yeah.
Okay. Yeah, that's great.
So question to Jay. You're saying this E2 will be consumed in 107 line, right?
Yeah, right.
But you can use it later after this call, or you need to return it and then you can use it.
No, like if he runs this code right now, it should break on line 108, or it shouldn't compile.
Because you are using the E2 the second time, right?
Yeah, exactly, because it's moved, so that value is no longer valid.
So if this event also contains this E2, but new reference, you can use it later, right? You can return it from this function and then create another one and then use it again, right?
Yeah, I mean, you can just clone them over and over, especially if they're immutable. There's a couple different ways you could do it. You could also make it like reference counted or something like that, depending on you know, if it was mutable, then you could use reference counting.
Yeah. So my plan for now is to have the events be immutable, and then like I'm starting to get the sense that if I wanted to have this as like outputs, then maybe I should have another struct called like output or something, and that's the one that should be able to, you know, be like moved here or consumed here or something.
Oh yeah, so not the entire event.
So this,
Yeah, right. Because if you think of a payment where I like, you know, take one of my UTXOs and I give some to you and some to Isaac and some back to myself, then like what we want to be consumed there is the outputs from the event, not the event itself.
Yeah, totally.
so you're like creating new edges. You're not storing the node. You're creating edges from E2. Right?
Mm-hmm.
Yeah.
Yeah, I like that.
Yeah, at this point, the events sort of like depend on parents in this really like abstract way that I haven't bothered to define. I didn't honestly even realize it until just now, but I think mostly just because they didn't define it that carefully in the consensus out, like in the Casanova paper. But yeah, basically all I've done at this point is enforce this concept that like events can have parents, like you know, event 5 can't go into the DAG, or it doesn't make sense to exist without event 2. For, you know, for whatever reason, like in some application, it might be because event 5 consumes an output that was created in event 2, but here there's no, it's event 5 depends on event 2 only because I said so right here, you know, not for any other like more high-minded reason.
Mm-hmm. Yeah.
So, Jade, how does I know, so like I'm in Python here now, and I know that Python uses a reference counting scheme for garbage collection. Is there something like that in Rust, like built in, that I can like opt into or something? Or you're thinking more of like it's not that hard to implement?
No, they have a couple primitives. They have the ref cell.
Yeah.
And then they have just RC, which is reference counting.
Okay.
And that's just a trait or something, or a struct that, you know, is a generic over literally anything. So you just throw it in that, and then you can have reference counting, and you can use the ref cell if you want mutability. But RC on its own will allow you to own something from multiple points, but it won't allow you to mutate it. It's just RC, like the letters.
What letter? Oh, C. Oh, count it.
Yeah.
Got it.
Yeah. Just RC.
Oh,
not
RC. Darn.
Yeah.
Okay, that actually makes a lot more sense since it's reference counting.
Yeah, exactly. Yeah.
Okay, cool.
Hey, Joshy, can I ask you a question about your outputs struct and how you would use that?
Yeah, sure. Yeah, totally.
Yeah, so I'm just trying to understand this a little bit better. So I think I understand why you're saying you can't use this E2 thing, right? You use some reference and then you don't have it anymore in line 108. I think I get that. So you're saying an alternative would be, instead of using the event directly, you're going to generate some outputs from the event, say like I don't know, 2.1 and E2.2 or something like that. And then so like this event E4 would consume, say, like E21, and this event E5 would consume E22 or something.
Exactly. Or it could even look, you know, like this. Like the first parent. Oh wait, no. Wait, what am I trying to think here? This is outputs, I guess.
Oh yeah.
Like the first output of E1. We were talking about E2, but that might be clear already.
Yeah.
And then like this one does like a different output or something like that.
Yeah, that makes sense. Cool.
Okay, let's see. Yeah. Okay, nice. So that's pretty much the test case there. Let's go back to the paper for just a sec. So it gives us 3 procedures: receive block, which that I basically already talked through this code. This is the one where you receive a block. If it can go in the DAG, it does. If not, it goes in pending. And then every time you receive a new block, you look through that pending set to see which ones can move into the DAG. This is, Jay, this is the part that I sent you snippets of code and was like cursing the borrow checker when I was trying to.
Did you sort through that?
No, but only because I didn't try again. When I got back to it, I decided a less frustrating way to start would be to write it all in Python, and so I did that. But I definitely am gonna. Okay, so the other one is receive event. This is not a very hard one. So like, basically, if the parents of the event are either already in your DAG or they're in this like waiting set, which is just other events that you're gonna put into the next block. So like basically, if you know all the parents, then just go ahead and add this event to the waiting set, and then that's it. So with blocks, if we didn't know all the parents to the block, we put them in this pending set and that all that stuff I just described. But with events, it's way simpler. Like if you don't know the parents of that event, just throw it away. It's like you never even heard it. And then, either that event also got sent to another validator who handled it properly, or the deployer can try again later once all the parents are better known or whatever. But it's like apparently not the validator's problem when it comes to events. And then they called this one time expire, but I called this one create block, and triggered it manually instead of like on a timer or whatever. But it's super simple. Like make a new block. Its parents are every leaf in the DAG. And so as an implementation detail, this is not specified here in the paper, but to implement this, I just cached, like I am always keeping track of like what nodes in the DAG are also leaves so that I can easily set up this new block. Take every event that was in your waiting set and make that the transactions of the block, clear out your waiting set, add the block to the DAG, and send it to the peers. So that part's pretty straightforward. And so I coded those up as receive event. That was basically just like a direct copy over. If E's parents are, I love that Python has these like operator notation for working on sets. So if its parents are a subset of the union of all of the other waiting events and all of the DAG events, then just go ahead and add it. And I'm just returning whether we like kept that block and or that event and we're gonna put it in a block, or false if we didn't have the parents, so we threw it away. And then create block is again just a direct translation of what was in the code, where like, okay, so I'm creating a new block. I'm giving it as parents all the DAG leaves. I'm giving it as transactions all of my whole waiting set. Here I mutate the waiting set to just put it back to empty. And then I call this helper, which is add block to DAG. And it does exactly what it sounds like, but it also, well, here's the comments I wrote. So add the block to the DAG set. That's the obvious part. Update the set of all events in the DAG. So I'm also keeping track of, whoops. Like over here, they were just telling me to like, okay, keep track of this DAG, right? But I found it helpful to keep track of the blocks that are in the DAG and then also the events that are in the DAG. And the reason that I did that was because when you get, it's up here, it's in this receive event. So like when I get a new event, I have to ask myself that question, like, okay, are all of this event's parents known? Like, are they in the DAG? And if I haven't kept a separate set of events that are in the DAG, then I have to traverse the DAG. And I didn't want to retraverse it every time just to see, like, are all the parents there? And I don't really have a good intuition about what the different costs are going to be with that trade-off. Like, obviously, it's going to be faster to keep a separate set of events, but it's also going to take a lot more memory, and then like maybe if this gets more serious, disk. So I haven't put a lot of thought into that yet.
Maybe a queue.
A queue of the events that I know. Yeah,
I mean, queue is like a set with a limited number of elements, right?
Oh.
You can put a weight, right? Which events you need the most, and like a catch.
Yeah. Oh, I just realized if we do think of this in terms of like C delta, it might make more sense to keep track of like what, maybe not the events themselves, but like what transaction outputs are still unspent, because that way when one gets spent, we can drop it from that cache entirely and never have to worry about it again. Yeah. And I think that's how Bitcoin does it. But anyway, but for now, I just have this like ever growing, linearly growing set of all the events that are in the DAG. So anyway, I was on this helper, add block to DAG, and anytime you're adding a new block, obviously put it in the DAG, and then also it's going to be a leaf, so put it in the set of leaves, and then update your set of leaves so that any blocks that are parents of the one you just added, they're no longer leaves, right? We just built something on top of them, so they're not leaves no more, so take them out of the leaf set.
So this operator is like a intersect for the sets.
Exactly. Yep. And it's specifically it's mutating this one on the left, DAG leaves.
Okay.
Yeah. And then finally, just add all the events in this block we just created to the set of DAG events. And I did this part here. At first, I thought it might make sense that just like whenever I'm creating a block, okay, go ahead and add its events to the DAG events. But the problem is we also want to do this for blocks that we receive from other validators that we didn't create ourselves. So it makes more sense to put it down here. And so the punchline, that's it. Like this is Casanova a test, and it seems to work so far. Although, as I mentioned, I didn't do like a very formal job testing it. I just wrote up parts that I thought of, and it seemed to work. So if I just get it back to the state, that part I want to keep, but this part I want to revert. Then I can run it for you. Okay, nice. So let me just, before we look at that, let me go back to what we're actually running here. So we created all the events. We sent them out to validators. Remember, Alice got 1, 2, 3. Bob got 1, 2, 4, 5. And then we printed out the states of the validators. So that's our first 2 lines here. So this is Alice. She just got a randomly assigned name. Her DAG has no blocks. She has no pending blocks. And she has 3 events in her waiting set. And likewise, Bob has 4 events, also no blocks anywhere. So then Alice creates a block and sends it to Bob. And then we print the next 2 lines. So here's Alice. She now has 1 block and no pending events. And this is where I encountered something that I don't know exactly how to solve, or I haven't thought about the right solution yet. So Bob has 1 block. That's good. He got it from Alice. He has no pending blocks. That makes sense because the block she sent him didn't have any parents, so he threw it in the DAG right away. And then he still has 4 waiting events. And the tricky part is 2 out of those 4 events are already in the DAG in Alice's block, in this block that he has over here, because she also received those events. So the question is, like, first of all, is that even a problem that needs to be fixed? And then if so, how to fix that?
Yeah, I mean, do you have a concept of equality on events?
Yeah, totally.
Yeah. So yeah, I mean, at the most basic level, you could just run through and cancel out, right?
Oh. Yeah, that's right. That doesn't seem as hard as I was thinking. So like here in receive event, oh no, not receive event. In receive block, yes.
Oh.
So like I guess the logic is, okay, so Bob receives a block from Alice. He looks through the events that are in it, and then if he has any of them, removes them from his waiting event set. Yeah, okay, good point. That doesn't seem so bad.
So waiting events are not checked. Are they already exist in the DAG, right?
Oh.
They're just waiting. Right?
Yeah, I think you're right. This is where I add stuff to the waiting list. So in the paper it says when you receive an event, if you know of all of its parents, either because they're in the DAG or they're in other events that are already waiting, then just go ahead and add that event. But yeah, it sounds maybe more like this. What it should be is you know, if you know these parents and you don't already have that event in your DAG. But that's not good enough, actually, because when Bob, even in this test scenario, when Bob received that event, he still would have added it to waiting because he didn't have it in his DAG yet, because he didn't have that block from Alice yet.
Yeah.
Maybe then every time you add a block to the DAG, yeah, you just delete all of those waiting events that were in that block.
Yeah, that makes sense. So that would be this one, receive block. So I wonder if that's in here. Let's see. So
It looks like they only say something about pending.
what was that?
It looks like they only say something about doing something with the pending set and not the waiting set at all in that receive block code.
Yeah, exactly. Oh yeah, in fact, this doesn't even reference the waiting set as a parameter.
Yeah, that's weird.
Yeah. So then the question is like, okay, is that just a little thing that they forgot to put in here because they were only writing pseudocode, or is there like some reason, like maybe it's okay to have the same event at two different places in the DAG?
Oh, but what does it mean when you clear the waiting list and time expire? Right, you're clearing the whole set.
Yeah, we're clearing that. So this is why, because we made this new block and we took everything that was in our waiting set and made it the transactions of that block. And then we put that block into the DAG. So we cleared it because we moved them over to an actual block in the DAG. Like they graduated, they're no longer waiting, they're accepted now.
Oh, I see why you called that create block, because you're literally taking these transactions that you know of and creating a block that has those transactions in it, and then clearing your waiting log or whatever, and then injecting that block into the DAG. That totally makes sense. That's weird to call it time expire, but whatever.
Yeah, my sense was like, okay, sure, putting that on a timer is one way to do it, but also like it seems like the validator could do it manually or whatever.
Yeah.
They say in the description, create a new block.
Yeah, exactly. Use that as my title instead.
So all of validators create a new block in Casanova, or is there a concept of leadership?
Yeah, there's no leaders in Casanova. Yep, anyone can create a block.
Why do they insist it's at a regular interval though?
Well, that's what I didn't get. Yeah.
Okay.
Yeah.
All right.
Well, okay, here's a question. Let's see what they do in the other ones.
Is this like a synchrony constraint that they enforce in this
Oh, that's a good question.
Yeah, maybe.
That's a good question. They called it time expire here also. Here's, okay, algorithm 3. They also called it time expire, and in Casanova, the final one, they also called it time expire. Yeah. And I think this is all that added. They're doing something about votes now.
So how is Casanova different from Hashgraph?
Yeah.
So if I remember Hashgraph right, the main gossip mechanism in Hashgraph is I call you up and say, here's everything I know about, and then you memorialize that in your like I don't remember the word, but like your timeline or whatever. And then in Casanova, when I create a block, I gossip it around to everybody. So, okay, yeah. So one difference is that the way they're gossiped, right? It's not I call you and tell you everything I know. It's I create a block and tell everyone about it. And then the other one is that in Hashgraph, you have the every like what they call events, like blocks basically have the self parent and the other parent. And then in Casanova, every block uses every known leaf when it was created as its parents. I don't know how fundamental those differences are.
Every known leaf?
Leaf. Like the at the bottom of the DAG, the ones that are not built on yet.
This is the block DAG, not the event DAG?
Exactly, the block DAG, yep.
Okay.
Yeah, right. So the events use as parents only the things that they depend on, right? When an event has a parent, it means this event doesn't make any sense unless this parent is also part of the history. But when blocks have parents, that's basically just saying like, look, here's how much DAG I knew about when I created this thing. Like in Casper, I think they called those justifications.
Yeah, yeah. But it wasn't for every leaf. It was for
That's
it was a
right.
proof for the current block. I
Yeah.
actually wonder about leaves. Like you could create a lot of leaves even in a proof of stake system by just sacrificing, the minimal amount of transactions required, or even by, faking it. I wonder if you could attack the system in that way by just creating a ton of leaves and then passing them around and filling up people's caches.
Ooh, that's an interesting thought. Yeah, I wonder. One way to, I don't know if this makes sense, but one thought I had is that we might be able to counteract that a little bit by so I know that there's a known and non-rotating validator set in Casanova. So I wonder if we could do something by well, I guess you'd have to quantify what the behavior is that you don't want. Like we'd have to formally specify what it means to create a bunch of leaves and send them around, but then maybe somehow slash the misbehaving validator or something.
Yeah, having the known validator set, I feel like really solves it, because you can, as soon as you prove that they're acting in a bad way, then you can ignore all the transactions.
Yeah, right.
And
Yeah.
that sort of relates to the ambience in that these validators are ambience. Well, almost everything's an ambience. The ambience like a namespace. It's it's the structure that we need. We have a few minutes left in consensus. I was wondering if how the notion of square root that Greg brought in relates to these different or relates to consensus. I'm wondering what people's ideas on that are, if they have what thinking on that is. Or we could just move that over into the computational count to this hour if we want to finish up stuff here.
So I feel like I'm done with Casanova, or I'm done explaining what I've done so far. I would need a briefing on the square root thing. I haven't heard the idea yet.
Yeah,
Yeah,
Jim,
me too.
I think so. During the Casper stand-up on Monday, that's where Greg has the opportunity to bring up some of his latest research. So this past Monday and the previous one, he's well, it's square root, and I'm going to be getting in over my head real quick here. Ultimately, it has to do with error correcting code. So, Jim, now, one thing I do know, in one of the upcoming RCAS talks, he'll be talking about this square root concept for error correcting code. So it's not the one that's out there now. I think it's going to be the next one. So, and during Casper, it's the first time that we're introduced to these new ideas, and he just kind of glosses over them, but then he goes back and he refines it and prepares. This is how he prepares the RCAS, and the Casper stand-up is kind of like the guinea pig. So there's more to come in the upcoming RCAS, where he'll get in more in depth as far as what the square roots, what it's all about. And I'll take a minute here to kind of think through what it is as we kind of carry on the conversation, to kind of maybe put it pieces together, because it's one thing to kind of hear it, and the other thing is to sit and think through and how it all comes together. So I'm not quite there yet, but Greg got excited about it, and he has all of the whenever he comes up with a new idea or research, he has all the reference papers that he called upon in order to create this new idea. So, and that's, and I think during the Casper stand-up, Gary, you were inquiring what that paper was. Cartier was the last name. It was a female mathematician. I never did come across what that paper was, but hopefully he'll also have the backup research for the square root and how he came up with it.
Well,
So
I think the one of the papers he was talking about was by this Paola Flocini, who is a computer scientist up in Canada, I think. But my take on it is he has seen I think he's recognized something in the nature of nodes running in parallel or processes running in parallel, and the duplication necessary. You know, what do they call it? Duplicate bits that are required for a certain number of bits of error correction.
Like how much redundancy, you mean?
Yeah, redundancy is the word I was looking for. And it seems to me he's recognized some sort of parallel between what we're already going to be doing in Rolang and in the nodes running these identical I don't know, virtual machines, whatever you want to call it. But it looks like, we're getting something for free out of this, which to me, it looks to be very exciting. And I say for free, we wouldn't be getting it if he hasn't recognized it. But
okay, I just had a little insight here. So, and this is just very high level as far as how the conversation went. So you, as Gary pointed out, you have all these parallel processes or pars going on. So what you do is you take the square root of the pars, and then you create a summation of all these pars, and then when you create the summation, and then when you break the summation back down again into smaller pieces, they're not the same. And that's where the error correcting code comes in, as far as now but that was the kind of the flow that he went to.
You definitely lost me in taking the square root of the pars.
Yeah, yeah.
Well, he pointed out that he pointed out. Go ahead, Joe.
If we look at the, I guess my take on it was more categorical, in that when we look at products of what is it, processes? I don't know. They're types ultimately, namespaces, but in constructing categorically the categorical products, we can look at and then, no, he lost me on it too.
Yeah.
Yeah. I mean, his discussions are based on technical papers that possibly represent people's life work. So, our Dunning-Kruger expert here can only do so much.
Right. And the thing is, if you know what a product is, and
if you can define like a field or something over, like if you can define a product space over parallels, where parallels are maybe like Cartesian products. Exactly. I mean, that doesn't exactly get you the square root though.
Yeah. There's some little missing thing there. But basically, you just although the error correcting code is only part of it. An example like I'm thinking it also could be related to Casanova or Casper or whatever. But from the error correcting code point of view, you're looking at the lack of consensus as errors. Okay.
Yeah.
Okay. And So when you have, so if things should be the same and you multiply them together, they should give you the same product. So it's just another way of looking at equivalence in my view. I'm not sure exactly what it adds to the picture.
Yeah, I wish we could give a little better. Even, I tell you, to give you a perspective, Vlad Samfir and Ken Shimaka, they were both on the call, and they, even with those great minds, they weren't they had questions as well. So, but it's, I think. When Greg does our cast, he'll have some hopefully he'll have some diagrams, because that goes a long way to help explain it. If you could see something and see what's going on, that's helpful. But this was his first effort at explaining this square root, so he'll refine his presentation, I'm sure. But ultimately, I guess what the end game is, it's coming up with an agreement for consensus. So it's ultimately it's coming to an agreement on a particular process or whatever it is. That's the ultimate. So you're going from the square root to consensus agreement, and all of these iterations in between that get you there.
Yeah, I mean, the paper almost sounds political. The one they all linked, it's called Population Protocols with Faulty Interactions, the Impact of a Leader.
Oh my.
Yeah, he says this is putting us smack dab in the middle of leader elections, and I'm not quite sure what that implies.
Yeah.
What was the title, Jay?
Population Protocols with Faulty Interactions, the Impact of a Leader. It's in the Consensus Colab. It's the ARCSID paper.
And I don't know that, is that the link that I put in there?
Yeah.
I'm not sure that that's the paper he's referring to, but I suspect that that's the author of the paper, looking at the material she researches and the title of that paper.
It definitely seems to be about like information theory and population dynamics for different impossibility theorems. I'm not entirely sure. It's really dense. Like.
Yeah.
So do we want to have a round of people's thoughts and then go on to computational calculus? I'll restart the recording.
I'm going to drop out for a little bit because I've got a parody thing I have to go to, but I'll be back probably in like 40 minutes if you guys are still around. And if not, I'll see you soon sometime.
All right, Joshy. Have a great day.
Thanks for showing us your code.
See you guys.
Thanks for the presentation.
Yeah, so the only thing that I know about this and through business is, I mean, through an analogy. I don't know any of the details. I haven't seen like a formal presentation of it yet. I think he intends to do that on the next RCAST call. But the analogy is basically like the par operator is like a multiplication in the terms of, it forms a monoid if you look at that fragment of the row calculus. But either way, you can think about it as like multiplication of real numbers or something, even like positive real numbers. But essentially the idea is the nth root of some process would be the same process that you would put in par with itself n times to reproduce this original process. Now, I don't know the exact details as to how that works, but it's, like I said, with an analogy to multiplication. And my understanding, I don't know how error correcting codes come into this business at all, but my understanding of it is then you can have n different validators that are all running this small piece of code, which when all of them run this, same piece of code in parallel, they can reproduce this larger term. That's my understanding of it. And so somehow it almost seems like he's suggesting that consensus is kind of built into the row calculus in a way, in this way where you can kind of reproduce these processes with like identical parts. And so thinking about like a validator running each one of these identical parts on their own machine to somehow create this bigger process. But that's about my understanding of this root stuff.
And to take that a step further, and I think the goal is to create some type of restriction in order to force a consensus. So if you have all of these nodes running these smaller bits and pieces, then what you do, he references this other paper where you take a summation. So you're taking a summation of all these processes, and then from that summation, then you break it down into the smaller pieces. And when you break it down once again, they're not the same. It's in a different. This is where you get these a restriction, and this restriction forces the consensus and agreement. So that's kind of what I gather.
Do we know what paper he's referring to in that case?
And it was a female mathematician, and I tried Googling it. It was Cartier and I've seen a reference to it before in one of the previous arcasts. He's referenced this paper a time or two. So, and I don't have the spelling, so I couldn't come up with it. But it's a paper based on summation that he kept talking about, summation of all these smaller pieces, and then breaking them down, you don't get the same thing again. And that's the part he was getting excited about, where he had that kind of like that aha moment. So, but he'll I'm sure he'll provide that paper reference in the next Arcast.
Yeah, like I said, I'm not familiar with the research. I don't know how the error correcting code comes into this whole system, but just from like the very small amount of explanation that I've heard, that's kind of my understanding.
Okay, very good.
Anything else before I end the recording, and we can start the computational calculus section?
Cool. Yeah, sounds good.